Hey guys, in this video we are going to learn how to solve a quadratic expression by completing the square. This is our third out of 4 methods. When we solve a quadratic equation, remember that we are looking for the x-intercepts of the function. So we're going to start off just by reviewing what it means to complete the square. When we've got a quadratic, and I focus on just the first 2 terms, I can figure out a number that I can add to those 2 terms that will make it a perfect square trinomial, which makes it very easy to factor. And that number is the ratio of b squared to 4a. Remember that b is the number that is in front of x, and a is the number in front of x squared. So I'm going to square 12 and divide it by 4 times 1. And when I do that, I end up with 36. So 36 is what I'm going to replace c with. So I have x squared plus 12x plus 36. Now factoring this becomes very easy. Because it's a perfect square trinomial, both of my factors will be exactly the same. They come from the square root of the first term, the sine of the second term, and the square root of the third term. And I end up with 2 of them. Okay? And this works. Remember that when you square something, you're multiplying it by itself. And if I multiplied this back out, I should end up with the same thing that I started with. And 6x plus 6x adds to make 12x. And that's what I started with right here. Okay, so this is my completed factored form once I've completed the square. So I'm going to do it again, but this time the sign in the middle is negative. So I write my b squared over 4a because I want to replace c with the number that is going to make z squared minus 26z plus c a perfect square trinomial. So I replace b with negative 26, and a is still 1. And I'm not sure what negative 26 squared is, so I'm going to put that in the calculator. It is very important that when you go to square a negative number that you put that number in parentheses first. And we end up with 676. Man, that's a big number. And when I divide 676 by 4, I end up with 169. So I've got z squared minus 26z plus 169. Well, what's the square root of 169? I don't know. So I hit second x squared. I type in my number and I hit enter and I get 13. All right, so my factors are the square root of the first piece. I bring the sign of the middle down and the square root of the back. Here are my factors with the completed square. So let's use this to solve some math problems. When we go to solve a quadratic by completing the square, we're going to start with everything on the same side, and we're going to look to factor out any greatest common factor. In this case, because x isn't 1, I don't have 1 to factor out. Step 2 says to move the variables to the left and the constants to the right side of the equation. Well, my variables are already on the left, so I'm going to add 15 to both sides of my equation. Now, x squared is a perfect square, so all I have to do is find b squared over 4a to complete my square. B is 14 and a is 1. 14 squared is 196. And when I divide that by 4, I'm going to end with 196 divided by 4. Oh, 49. So here's my new C term. But if I add 49 on the left, I also have to add it to the right. And 15 plus 49 is 64. So now I'm going to take this perfect square trinomial that I made, and factoring it is really simple. It's x, square root of the front, sine of the middle, and square root of the back. Okay. So I've got x plus 7 squared equals 64. And now, and the whole point of using completing the square to solve a quadratic is that we make something that we can solve using the square root method. So now I'm going to take the square root of both sides. And remember, when we take the square root of both sides, my equation splits into 2. X plus 7 equals positive 8, but x plus 7 also equals negative 8. I subtract 7 from both sides. X equals 1. I subtract 7 from both sides, and x equals negative 15. So this quadratic that we started with has two x-intercepts, one at positive 1 and one at negative 15. In example number 3, A isn't a perfect square, but, well, A is a perfect square, even though it's not 1. So, I can use this completing the square method to solve this quadratic. So I draw my dividing line. I'm going to subtract 12 from both sides. So I've got 4x squared minus 16x, and I'm going to leave some space, equals negative 12. Okay? So now I'm going to use that b squared over 4a. So I've got negative 16 squared divided by 4 times 4. Well, negative 16 squared is 256, and 4 times 4 is 16. (256) divided by 16. Oh, yeah, it's 16, which is the number that we multiplied to get 256. So the number that's going to complete my square is 16. So I'm going to add 16 to both sides. Now, factoring on the left becomes simple. It's the square root of the front. You bring down the sine of the middle. and the square root of the back. And square it. And that is equal to 4. So now we're ready to solve this quadratic using the square root method. Take the square root of both sides, and right here my equation splits into 2. 2x minus 4 equals positive 2, and 2x minus 4 equals negative 2. Now I've got a slightly more complicated problem to solve than the last one, but it's still a two-step. So I draw my dividing lines. I add 4 to both sides. I have 2x equals 6 and 2x equals 2. And then I divide both sides by 2 to get my x-intercepts and my solutions to these equations. So this quadratic has two x-intercepts, one at positive 3 and one at positive 1. All right, so I'm going to do this one more time. This time, I'm already set up. I don't need to move anything over because I've got my x terms on the left and my constant on the right. A is a perfect square, so I'm good. I'm ready to find b squared over 4a. We've got 4 squared divided by 4 times 1. So it's 16 divided by 4, which is 4. So I'm going to add 4 to both sides. Okay. Now I'm ready to factor. Square root of the front, sign in front of x, square root of the back, and I square that binomial. I take the square root of both sides, and I split my equation into 2. So I've got x plus 2 equals positive 4, and x plus 2 equals negative 4. Draw your dividing line, and you've got a one-step equation to solve. My two x-intercepts are x equals negative 6 and x equals 2. All right, so here's our application problem. The length of Bill's backyard swimming pool is 60 feet longer than the width. The surface area of the water is 1,600 square feet. What is the width and length of the pool? All right, so this is an area problem, and it tells me that the area is equal to 1,600 square feet. And I know that area of a rectangle is length times width. Now what do I do here? Well, I've got two factors, but it's not equal to 0, so I can't solve by factoring yet. So I'm going to try and multiply this out. Oh, hey. I've got my x terms on the left and a constant on the right. I'm going to use completing the square. So I've got b squared over 4a that I need to find, and I'm going to add that to both sides. So 60 squared divided by 4 times 1. Man, I don't know what 60 squared is. 60 squared is 3,600, and I'm going to go ahead and divide that by 4, and I end up with 900. So I'm going to add 900 to both sides of my equation. Okay, so now I'm ready to factor out the left side. Square root of the front, sine of the middle, square root of the back. So I'm going to take the square root of 900, and I get 30. And I square the whole thing, and it's set equal to 2,500. So I draw my dividing line. I'm ready to take the square root of both sides. And remember, right here, your equation is going to split into two pieces. I've got x plus 30 is equal to, what's the square root of 2,500? 50. So I've got x plus 30 equals 50, and x plus 30 equals negative 50. And to solve for my intercepts, I just subtract 30 from both sides, and I get x equals negative 80, and x equals 20. So I've got two solutions to this quadratic, but only one of them is going to make sense. How can the width or length of a pool be negative 80? It can't. So this solution that we've got of negative 80 does not actually work for our word problem. And remember, as I mentioned in a previous video, odds are that only one of the answers from your quadratic are going to satisfy. So here's the answer that we're going to work with. So now the question said, what is the width and length of the pool? All I have to do now is plug in my numbers. So my length was x plus 60. So I'm going to replace x with 20. And the length of my pool is 80. And it's 80 feet. The width of the pool was just x. So the width is 20 feet. And there is the solution to your application. All right, so now it's your turn. Complete the following practice problems. Make sure to have them checked before moving on.